Okay, sorry, I just realized I was not recording, so I'm kind of go over what I just did. And I don't have another sheet, so I gotta kind of go through it. So difference of squares, what I did was, so we reviewed what we did previously. So we used FOIL method when we just had two parentheses that were like, except as one positive, one negative. So if we do FOIL here, we do x times x, which is x squared, x times negative 4, which is negative 4x. 4 times x is going to give us 4x, and 4 times negative 4, which is negative 16. Our middle terms canceled, and that left us with x squared. I'll do another example since I wasn't recording the first time. Here we have 5 times 5x, that's going to give us 25x squared. 5 times negative 1 gives us negative 5x. Our inner term, 1 times 5x is going to give us a positive 5x. And then 1 times negative 1 gives us negative 1. We see our middle terms cancel, and it's 25x squared minus 1. And if you want to pause and try this, the third one, you can. But here's my answer, 4a squared minus 9b squared, because our middle terms cancel. Got it? So that's what we did previously with FOIL method, and we got a difference of square. Now we're saying, how do we go backwards and factor to get a difference of square? Difference means subtraction, so there has to be a minus sign in the middle. Got it? And then square, of course, square means you take the square root. So to factor a difference of squares, use the following rule. You take the square root of the first and the last term. So square root of a squared is going to be a times a. Square root of b squared is going to be b times b. And since it has that minus sign, it means it's a difference of squares. So that means we have opposite signs, a positive and a negative. Has to be opposite so that the middle terms can cancel out. I'll work out some examples. Those are the ones I was doing before I realized I didn't record. But if I recap it, square root of a squared is a and a. Square root of 4 is 2 and 2. And they have opposite signs. I'll do another one here. So we have c squared minus 100. See that minus sign, so we know it's going to be a difference of squares. So we have one positive, one negative. Square root of c squared is going to be c times c. Square root of 100 is 10 times 10. And there's an answer. And if you want to check it, you could do FOIL method. The middle term should cancel out those 10 c's. And then that's why we're left with 2 terms. Got it? Look at number 5. It says k squared plus 25. That's our answer. That's it. That's the only factor. It's prime. It has a plus sign, so you can't do the difference of squares. Because if you did k and 25 and 25, you have a plus sign, so I mean both are positive, so the middle term is not going to cancel out, so that's as far as we can go. Everybody got it? Okay. Okay, look at number 6. So number 6 we see is kind of not written in the correct order, so I'm going to bring my y squared up to the front, and then my plus 1. So in this case, we look at it and we're like, oh, okay, it's a positive. But we have that negative in the front. So what could we do here? You said it. Hopefully you said it. You can pull out a GCF of a negative 1. And what that will leave us with is a positive 49y squared, because if you distribute that, it comes back to negative. And then we have negative 1. So if you were to go backwards, you say, okay, distribute that, gives us negative 49 squared. Negative times negative brings us back to positive 1. So it's still the same answer. Now we have a difference in squares, so we can factor this middle term, right? So remember the GCF stays outside. We have a positive, and then we have one negative, right? Square root of 49 is 7 and 7. And then that's y squared, so it's going to be 7y and 7y. Got it? Square root of 1 is 1 and 1. And so now there's our answer. And that happened by pulling out the GCF of negative. In this one, it was just positive, so we couldn't pull out a GCF of negative, so it was just prime. Got it? Okay, we add in a few variables. Here we have 9b squared minus 100. So 1 positive, 1 negative. Take the square root of that. We have 3b and 3b. Square root of 100, we have 10 and 10. And so there's our answer. The middle terms will be negative 30 and a positive 30, which would cancel. And that brings us to that. Everybody got it? Okay, let's try one where it brings in 2 variables. Okay, we'll look at 12. So we see it as a negative, so we have 1 positive, 1 negative. Square root of 64 is going to be 8u, 64u squared, and 8u. Square root of v squared is v and v. See, difference of squares is pretty simple. And I do one with two variables together. X squared, y squared, square root of that is going to give us xy minus square root of 1. And then xy plus 1. Everybody got that? Soak it in. Alright, now let's look at the back. So back here we're going to do just a few of them where it brings the GCF in. Okay. So here we see it's a difference of squares because it has a minus sign, but then you might look at it and be like, there's no square root of 24 and there's no square root of 54. So then you have to think to yourself, okay, it might have a GCF, because remember, if all else fails, look for a GCF. So if we look for our GCF, we see both of them are divisible by what? 2. So if we take out a 2, no, 2 is not going to work. No, yeah. Okay, we could pull out a 2. And so that will leave us with 12a squared minus 27b squared, right? Just double checking. Okay. I'm doing this the same time y'all doing it. But if you look, we still can pull a 3 out of both. So let's scratch that. Let's pull a 6 out. So we get both of them divisible by 6. And I'm sure somebody said it in class. So if we pull a 6 out, 24 divided by 6 leaves us with 4a squared. And then 54 divided by 6 leaves us with 9b squared. Now, that's the greatest common factor. If we pulled a 2 out, you would have saw I could have pulled another 3 out. And so 3 times 2 means the GCF is 6. So plus 6. So now I have a difference of square where I have a perfect square I could take the square root of. Don't forget we have to leave a 6 on the outside. So square root of 4a squared is going to be 2a and 2a. We have our opposite signs. Square root of 9b squared is going to be 3b and 3b. And there we factor with the GCF. Everybody got it? I'll try one more. Let's look at 32. So 32, what would the GCF be here? We could pull out a 2. Is 32 divisible by anything else? I think that's it. I might be wrong. If I am, don't worry, I'll correct myself. I'm just human. Okay, so we pull out a 2. That will leave us with 16s squared. And then we pull out 2 out of here, and that leaves us with 9u squared. Okay, yeah, I'm right. That's the GCF. Now we can take the square root of both of those. We have a 2 on the outside. Opposite sign, square root of 16 is 4s and 4s. Square root of 9u squared is 3u and 3u. Got it? And there's one more small thing I'm going to go over, but I don't really like going over perfect squares because some people want to use a shortcut for everything. Don't use the shortcut, but there's an opposite of difference of squares. It's perfect squares. And we've done this before, but I want to show you. So here is what we call a perfect square, and you wouldn't know it until, so if you were to factor using the regular factoring method, AC times B, it's supposed to equal B. We see our AC is 36, right? And we're trying to equal the middle term of 12. So we have 1 times 36. 36 is also divisible by 2, and that would give us 2 and 18. It also can go into 3. 36 times 3 is 12. I'm running out of room. Skip all the way down, so let's get to 6 times 6. So these right here, they won't work. That's going to be 37. Why did I do 2 times 8? Oh, that's supposed to be 18. I can't read my own handwriting again. 18 and 2 is going to give us 20. 12 and 3 is going to give us 15. 36 and 6 is going to give us 36, right? So that's the one that works. And this is a perfect square because look, that means the parentheses are going to be identical with 6 and 6. So we end up with x plus 6 and x plus 6. And so remember, another way we could write that is x plus 6 squared. So we've done problems where we had the squared and we said, oh, we have to write it twice. It actually has a name for it. It's called a perfect square trinomial. Oh, these problems are not on your paper. I just crossed out 29 and 30 and added them in. So if you want to add them in. So we'll look at one more. So 30, I crossed it out and wrote 4x squared minus 16x plus 16. So here's another perfect square trinomial. And we can tell it because we could take a square root of 4x squared, which is 2x and 2x. Take a square root of 16, which is 4 and 4. First sign's a negative. We know a negative times a positive is going to be a negative. And so that's another example of a perfect square trinomial. And we can write that as 2x minus 4 squared. Now, some people try and use perfect square trinomial for everything. Everything's not perfect. If you could take the square root of the first and last term, that doesn't mean it's perfect. So double check using FOIL or scratch it. Don't even learn perfect square trinomials. Just stick with factoring them all using T-charts, slip and slide method, reverse window pane, the district method with the grouping of the factoring tree. So I'm just showing you how we get those that have squared, but just use your regular methods. That pretty much sums it up. Pretty easy lesson today. Have fun and see you in one day, Wednesday.